Hello everyone. I just, not today, I think, maybe last week, I watched one of the number file videos. One interesting thing, it's just animation and adding the sounds. Did sound kind of interesting. I'll just play it. Anyways, I was thinking maybe I should try to implement these sort of things by myself. Maybe I'll just record it and make the YouTube video, I guess. How did I make it? Let's make the directory and call it Hanoi or something. Let's call it Hanoi. Create directory Hanoi. Let's make main include SDLPP SDLPP.hpp SDL init. I need to put here what I want to initialize, what kind of flags, and SDL init, what kind of flags we can have here, specified by flags. Here we go. I guess I need video and audio, and I guess that's it. It's compiled. I do not remember too much about how I supposed to do things with SDLs. Oh, I should have some examples. No, not some. Oh, here we go. Examples. Init, and we can create window SDL window, and it would be Hanoi. Let's call it tower of Hanoi. Let's put same stuff, 126 width and height, and SDL window borderless const auto 1280 const height equals 720 wget. I have no idea what is -1 and 0 means, but let's do our, I'm just going to copy paste. So let's do delay for 1 second and see how it's gonna work. I think I can do it this way. SDL delay. Okay, it's compiled. Also, this thing I can do auto equals, so we will embrace auto everywhere. So let's see if it will draw anything on the screen. Yeah, it did draw for 1 second. That's good. But there is a algorithm to solve Hanoi Tower. It's very simple. Solve. We need to say what we want to do. We want to move tower and the height of the tower, I think, and from which pin to which pin. Int height and int pin 1, int pin 2. What we need to do, we need to do solve and move height -1 from pin 1 to, let's do int pin 3 for simplicity. We need to do move from pin 1 to pin 3 and use pin 2 as support pin, and then we move from pin 1 to pin 2, and then we move everything from pin 3 to pin 2 using pin 1 as support. I think that makes sense. If height is 0, we just return, and we need move int pin 1, int pin 2, and we can for now just print out the thing that cout move pin 1, pin 2. Let's run it here. Let's do for free. We want to move from pin 0 to pin 1 and use pin 2 as support. So let's see. 0 to 1, 0 to 2, 0 to 1, 0 to 2, 1 to 2, 0 to 1, 2 to 0, 2 to 1, 0 to... Yeah, look at this. I nailed the solver. And now I can make this one as a class, I guess, class Hanoi public, and it will take renderer auto, and we can just run solve. I can maybe just put 3 here. In the constructor, we will take the renderer. This can take n, and this one can become private, and we can just, and everything can become private, and we can just call solve immediately, and 0 1 2 cout move pin 1 pin 2. I need to reorganize stuff. So it's going to be compilation here, and it's going to be debugger here. So it's not happy, or does not. Oh, okay. We need DL renderer. I'll just make it reference. It should be fine. And int n. Actually, I don't need end here. Solve. Oh, really? I can do it this way, I guess. Oops. Missing semicolon. Solve. And I don't need solve. Private field. It's fine. We should get similar results. More or less similar. Now, in the move, first, as I can populate a tower, pre-populate the tower here, and it's gonna be stand array of vectors, vector of integers, 3 tower. In the constructor here, we will pre-populate it for I equals 0, I less than n, plus plus I, tower 0. And what we need to push back from biggest to smallest n minus I minus 1. Okay, now in the move, I can do auto the disk, right? Disk equals tower back, tower pin 1 dot back, and tower pin 1 pop back, tower pin 2 push back disk. And we can I guess visualize it for I equals 0, I less than 3, plus plus I for disk out of tower I. I will visualize it in the console. I think that's good. Maybe I'll add like a extra space to make it easier to read. And let's run it. And let's see. Okay, so 0 went to 1. Yeah, look at this. It's kind of sideways, but 0 went to 1. We can more or less understand what is going on. And yeah, at the end of the day, it's moved from pin 0 to middle pin. And now we can also visualize this thing because we have R. What we can do, we can clear draw stuff, set draw color, clear set draw color, and we can draw the disk here. What is this thing? Oh, okay. X is I need to put this thing here. I don't need start. Yeah, it's okay. Okay, I need to split screen to 4 times, we divide by 4, and we need to add 1 to I. Yeah, that should be fine. Unsigned into int. This becomes unsigned. Okay, Y position. I don't know, maybe minus 20. And let's make 18, so we will have 2 pixels gap, and we can put delay here for 1 second. We need the size, disk size here. This is going to be disk plus 10 times 20. I'll just making up everything. Const auto size equals. So let's make size here. And what we need to do, we need to subtract size, divide by 2. And we can put sleep SDL delay. Let's make it 4 times faster here, and let's make it 8 high. Why I started all this shenanigan, I want to make a sound. Let's figure out how to make the sound. Where did I do any sounds? Last time I did it here in the spectrogram. Audio capture. Here, this one is going to play stuff. Audio, play frequency, play volume. Oh yeah, I think that's simple enough. and I can make these variables global. I need want, and the want is this guy. Can call it const also. So I believe it should compile sample frequency. This one also static. Let's do 48. Play frequency. Oh, we do not need to capture all of them. That's good. And let's it is already initialized, so it's gonna start playing immediately, so be prepared. Huh. It did make the sound, but play wall greater than wall. Wall equals play wall. Not sure what's going on, why it's not working. Let's make it 0.5, I guess. Okay, it's working and it's very loud. My ears. Okay, let me make it to decay. Play equals 0.999. Wall is unused. Makes sense. Cool. Now I can do stuff here. Our pin, smaller the pin, the higher note. There are 0. Okay, let's do state array of integer, and we need 8, and it's gonna be notes equals. Smallest one is going to be highest one, so it's going to be 12, and then we are going to go down on major scale, so it's 11, tone 9, tone 7, tone 5, semitone 4, tone 2, tone 0. Disk what we are moving is going to specify the frequency. Play volume, we start from 0. Frequency, play frequency equals to let's do 40 times power 2 in power of n divided by 12, and it's going to be nodes disk. Play frequency and play volume is going to be like this. Let's see. It's working. That's surprisingly